Once again, everybody is welcome here. Now, the last time we wrote a general panel data model. I just want to show you the model, then we just refresh our mind. The general panel data model. This was the general panel data model. And we were able to explain the details. But you can see that in this second panel data model, the one just below, I did not bring the intercept like the first one. And generally, when you're writing panel data models, you may not bring the intercept, because they are all absorbed or into the unobserved heterogeneity. We're able to explain this terminology called the unobserved heterogeneity. We explained the time heterogeneity. This one was the unobserved individual heterogeneity. Then this was the time heterogeneity. And finally, the idiosyncratic error, the epsilon. We're able to explain each one of it. A typical real-life data, which are used in one paper I published in the Journal of Regression Insurance, actually. This was a recalculated productivity indices represented by I. Okay. And in this productivity index, which was a post-Malmquist productivity index, you can see that I didn't bring the constant. It was dependent on whether the company is live or non-live, whether the insurance company was a live or non-live. It was dependent on the capital ratio, or the credit risk. Okay. It was also dependent on the leverage. Now, if you look at the live and the non-live, okay, these were actually given as I and T because some of the firms could be interchanging in their process. So it was changing across individuals and across time. Now, it was also dependent on the log of the total asset. This is a real life situation. And then it was dependent on GDP, but GDP was not individual dependent. It was time varying, but individual, non-varying. It was individual non-varying. So you can see that it had only a subscript of T. Inflation, the same. It was changing across time, but not across firms, because all firms face the same inflation. And this was also pure technical efficiency, changing across individuals and across time, scale efficiency, changing across individual and across time. And then we had regulation. The regulation was changing across time, but not across individual. Now, if life and non-life were not changing, it would have been static. It would have been a static dummy variable. So you would have only had the I and not the T associated with it. So whenever you are formulating, modeling, you need to know which ones will have I, which ones will have T, which ones will have a subscript of both I and T. Because when you model wrongly, that will be affected. Of course, the lambda T captures all time dummies. And then the UI represents the unobserved individual specific effect, whereas the EIT is a usual random noise. So this was a typical model that we have. Now, the lambda T, which is the time dummies, okay, it reflects the combined effect of many factors that are time constant variables. Okay. And that is why we exclude it in the intercept here. Okay, we exclude the intercept time in the formulation. So you can see that this time dummy, it will capture the intercept. So if the intercept was there at all, it will capture it. And the most important thing we're going to do today is this, that anytime you do this panel data modeling, you are going to get different models depending on how you model the unobserved heterogeneity. Guys, this is the main deal. This is the main deal when it comes to panel data econometrics, the unobserved heterogeneity, the UI. That is a real deal. And that is what makes the big difference. So you will see in some of the papers I'll give you that some people will not capture that. They will not consider that. They will be mute when it comes to the unobserved heterogeneity. And that is a way for you to be able to handle that. You will see it. Many people write papers, they don't talk about how they control for unobserved heterogeneity, how they control for cross-sectional dependencies, how to control for serial correlations, how to control for heteroscedasticity. They don't mention that, how they control for possible endogeneity. These things have to be handled, spoken of, dealt with, so that you can have a robust work. Okay, so we're going to use the wage pan data to explain. And all of you have got a wage pan data. It's a panel data, it's in a long form, okay? And I'll be talking about it very soon. It's a very real data, and we are going to give it a title so that it's like we are writing a thesis or a paper. Okay? We have a hypothesis, everything, motivation and everything. We're going to give it a title. And this is a title we are going to give to that. This is a title that we are going to give to that particular Excel data that we have. You're going to give it a title, which is like you are writing a journal. Okay. You're going to give it a title, and they use that title to guide. Now, the information in the data is very important. Okay. In fact, let me first show you the data. This is a data set. I hope you can see it. Okay. This is a data set. We'll come back to it very soon, because first, let me give it a title. And this title is already something that is there, because the data was a data used by some authors in the past, Vivek and others in the past, to actually work. Vela and Vivek in 1998, they analyzed this data. They took it from the National Longitudinal Survey. It has to do with youth. Some young people, you know, who are between the ages of 17 to 20 something. They have just come out of the school and they have been employed. And they started working from 1980 to 1987. There are 554 full-time working males. They were all boys. And this data, we've given it a title called Whose Wages Do Unions Raise? A dynamic model of unionism and wage determination for young men. Now, the title might look a little bit strange to you, but it's very simple. The question is, unions, whose wages do they raise? Do they raise the union members their wages, or the non-union members their wages, or everybody's wages? So when you are in a company and you have the unions, do the unions activity, do those activities help everybody? And that's the first thing. The second thing is, does a person's wage, or is a person's wage affected by the person being in a union or not? Okay. And we will look at something related to the person's education as well. The data is a balanced panel data. Now you will understand when I say that. Okay. But for some years, you will notice that it wasn't balanced. Okay. But the original data is a balanced panel data. 554 individuals, 8 years. So how many observations are we talking about? 554 people over 10 years. So how many observations? So you have a 8-year panel data by how many observations? Who can guess? Who can tell us? Okay. Who can guess and tell us the year? You just multiply 545 by 8, and that will give you that. Okay, so look at the data a little bit. I just want you to have a feel of the data, because I want you to understand when you collect your data and you want it to be paneled, this is how it's got to be. The ID refers to the names of the people. If it was companies, it would be like 13 would be like EcoBank, and all of that. Then the next one will be GCB, 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 and all that. Okay. So you can see that the first, this is the information, 8-year information. Somebody's giving me the observations, 4,360. Good. The next column is always the year. So you can see that for this particular ID representing the individual, okay, that individual in the year 1980, okay, that is what you see the information there. And you can see the ages, okay. As at the time they began working, that person's age, okay, and then you have the experience. If you look at it carefully, you will notice that the experience, depending on when the person actually joined the organization, okay, the person will have 1 year experience and it will be increasing deterministically. The experience will be increasing. This is the union is an important variable. If you see it as 0, 1, 0, 1, but we'll treat it not as a dummy variable because a person can move from being in a union to not being in a union and can move from being not in a union to being in a union over that time period. You can be jumping, I don't know, from being a union. So union will be featured as a changing variable. Married would also be featured as a changing variable in this case, even though married might look, of course, like a dummy. The answer is because a student, a person who is working over that 8-year period, because they are young, remember, they are 17 years upward. So such person can change from being single to married. Okay. So you can see that some of them will be single, then they can, yes, married, and all that. Okay. Ethnicity will be a dummy variable, a pure dummy. There are all kinds of ethnicity, or it's also called race. Okay, let me just show you something here. It's also called race. Okay. Race. Okay. So let me just mention this, that the youth have just completed their schooling by 1980. I've said this before, and they have been working from 80 to 87. The sample are young. The age are in 1980 ranging from 17 to 23 years. So they are young, they would want to marry over the period. If somebody is 23, it means by the 8-year period, the person is like 31. So that person might have married. So that's why you can say that marriage is changing. Sorry. They entered the labor market fairly recently, so they have an average of 3 years of experience already in the beginning of the sample. So you can see that in the beginning of the sample, some of them's experience, let me show you. Experience, some of them are 1 year experience at the 1980. But if you look at this guy here, okay, you look at this guy, at the time of 1980, his experience was 4 years. Okay. So some of them have got experience already. If you look at this guy, at the time of the 4 years, at the time of 1980, he was 4 years experienced. Okay. So they differ, from person to person. This person, for example, you can see that at the time of the 1980 of entering the labor market, his experience was 2 years. All right. So this is just for you to fill it. Let's continue and have a feel of the data. It's always good you have a feel of the data. Okay. So these are the information. Experience computed as age minus the 6 years minus schooling. Union, as I've explained it, is the wage is set by collective bargaining. Okay, and it's equal to 1 if a person belongs to a union or 0 if not. Married is the individual, whether he's married or not. Ethnicity is whether the person is Black, Hispanic, or other. Disability means that a person, yes means that a person is disabled, and no means the person has no disability. So you can feel the data right. And does the individual live in a rural area? Okay, there's a value for rural. Okay. When you check it here, you can see that for rural here. Okay. Now, Gilbert Mombaza, you've got a question. So it is important to understand all of this. Okay. Now, there are other things we will not use for this purpose. The key, one variable we use is the hourly wage in dollars. So that one we'll use. Okay. The sector the person is working in. Okay. and some dummy variable. The occupation the person is working in, the years of schooling, the natural log of the wage, and then every year is considered as a dummy. This dummy you have to understand, and we'll look at it deeply. Okay. So this is just a feel of the information that you have there. Let me take you back. So the variables I've actually greened them are the variables we've been working most with. The ones I've given them green colors. The wage is important, but you come to later learn why we are not taking the wage, but we are taking the log of the wage, the log of the wage. The education is also there, okay? The years of schooling of the person is there. Experience has been there, but experience is also squared. So when you look on the far left here, experience is there, expire is there, and then on the right, you have experience squared. You're going to learn why that is so. And then of course you have dummy variables for all the time. These are the lambda t. Okay. They are changing with time. They're changing with time. They're not changing with individual. They're changing with time. Okay. Any question on that? Someone says, the person says, what is the difference between the two data sets, wage pan dummy and wage pan? Oh, somebody says, what's the difference between the wage pan dummy and then the wage pan? Now the wage pan, what happens is that I created more dummies. So if you look at something like the wage pan dummy, okay, if you look at something like occupation, okay, occupation, I use actual names under occupation. I use the actual name, service, craft form, manufacturing, and all of that. But when you go to the wage pan, what I did is I created a dummy for each occupation. So occupation 1, create a dummy for occupation 2, create a dummy for occupation 3, create a dummy. So create a dummy, just to ensure that everything is numbers. Numbers. No writing, no dummy writing, but they are all coded as numbers. Other than that, that's it. But the best one to use is a wage pan dummy and not the wage pan. Somebody said, why are you using wage pan for this study and not the wage pan dummy? I'm using the wage pan dummy. I'm using the wage pan dummy, but just that in the document, in your Word document, I call it wage pan. I name it any way I want to name it, but then this is the very one we are going to use. The one you are seeing on your screen, this is the one you are going to use. So don't worry about the type of data you're going to use. We are using the wage pan dummy. I could have called that one to W. Okay, I could have called that one W. But I just wanted to know that it's a dummy variable. That's why I called it. Okay, dummy variable, you write it in English. Okay, all right. Let's move on with this. So now you have a feel of the data. At least the key important thing is that you have a feel of the data. Now, usually there are research questions you ask yourself. When you have collected, you've given a title to your work, you write your introduction, you write your problem statement, you write your motivation, justification for the study, you criticize other papers who have come closer to your work you're doing, you punish the papers, you criticize their methodologies, you criticize their sample, their theoretical perspectives, and then you write your objectives and then your research questions. So I have some couple of research questions that we'll post here, and then later on we'll answer them. Question number 1. Has the return to education changed over time? The return to education is your wage. Has it changed over time? So this is where you're going to use a time dummy to detect whether it has changed over time. And you'll see it very, very soon when we get there. Next question. What is the impact of unions on wages? You remember the whole topic was about the impact of unionism. Okay. Whose wages do union raise? A dynamic model of unionism and wage determination for young people. So the question, the research question, what is the effect of unions? Is belonging to unions powerful in increasing your wage? How does this vary by worker characteristics? Okay, those are some of the questions. We won't answer that last question. What are the key forms of worker heterogeneity generating the endogeneity of union status? Of course, if you have more questions, you ask. I ask some questions. Doesn't mean that you should ask some Questions here. With what form of economic sorting behavior? In fact, you can change all of these questions to your own questions that you would have also asked. So normally, that's what we do. We pose research questions and we let the data solve it for us. So how do we proceed? Well, before we proceed, there are important things you need to know about this. One, there are some variables in the panel data. They are called varying variables. Please note the word non-constant variables. They are varying. They are not constant. They are not fixed. They are varying. They are not constant. They are not fixed. They are varying. Some variables are changing. Over time, they are changing. In this story, and some of them might shock you, so I want to take note why. In this story, one of them is experience. Experience is a varying variable. Please note, later on, you come to realize that we will treat it as not varying. Marital status is varying. Do you remember I told you that these are young people from the ages of 17 to 23. So over the sample period, they will marry. So marital status is varying. So you got to make the assumptions ahead of time into your model. You got to make that clear. Union is varying. Why? Because we made it clear that these people can jump from belonging to a union or not belonging to a union over the sample period. So those are the varying variables. What about the non-varying variables? The fixed variables, the constant variables, those that are not changing. Well, race is one of them. Your race, whether you are Black, Hispanic, or other, that is not changing. It's fixed. It's quite strange to say that education is fixed. Yes, because these young people are between the ages of 17 to 23. They just entered the labor market. They do not intend, we made assumption that they do not intend going to school over that 8-year period. They are here to make money. And so education is considered as fixed. And so the person's education that he had, okay, the person's education he had at the time of 1980, that education is fixed. It's not going to be increasing or decreasing. Then experience. Okay. Now, it's quite strange. Watch it. Experience is here considered as varying. Experience is here considered as fixed. Now, this is how you consider it. Okay. It's how you view it. And you will get to know this later. Okay. Even education, okay, the reason why we considered it as fixed is because it may not exactly be fixed, but might roughly be constant over 5 years. Because we said that over that period, a child might not what? Might not go to school. But some of the variables that you have considered them to be fixed, you can interact them with the year dummy. So you can interact education with 1981. You can, why are you doing that? Because you want to test if the wages was constant over this period of time. Whether that return to education was constant. Now, if gender were here, if there were females, gender would have been part of the fixed variables. But remember, we have only men. Now, the unobserved heterogeneity, the UI, it captures all of these fixed variables. So the variables that are fixed, they are all contained. They will be contained inside the unobserved heterogeneity. So keep some of those things in mind. Now, some of the variables are logged. When you go and check carefully, you will notice that, let me take you back there. Okay. And some of you will have to do this in your work. Look at the wages. I've taken the log of the wage. Why? Why? Why are you logging the wage? Who can tell me? Who can tell me why we log some of the variables? Who has an idea? Who can guess why do you have to log some variables? Anybody? But sometimes I want you to think a bit. Okay, if I tell you, why do you log some of the variables? Why do you think you have to take the natural log of some of the variables? Who is bold? All right, somebody is raised a hand, somebody has answered, but let me just pick the one who is raised a hand. Eric, hear me. Eric, why?
You take the log to control for any changes, any size effect or inflation.
Any size effect. So can we take the log of ethnicity?
No.
Why not?
No, because that is a categorical variable.
Okay, so let me pick a variable that is not categorical. Can we take the log of education?
No, we cannot do that.
Why not? It's not a categorical variable.
No, we cannot do that. With regards to wage, because there's...
Oh, you forget about wage. When do we have to take the log of what variable?
No, I'm thinking that you take the log because you want to control for any fluctuations or inflation in the numbers. So, for example, with education, that will not apply.
So mention certain things in life that we can take the log then.
Okay, I'll bring it to, say if I'm doing a brand assessment, let me say brand awareness, brand association, for example, and say I have a brand like MTN and I have a brand like Tigo. If I am assessing the image, because the bigger brand would mostly have more people aware about it, it would skew the data. So usually I'll take a log of all the awareness so that it corrects for size effects. So that's an example. I don't know if that works.
All right.
Yes.
Okay, nice try. Thank you for the attempt that you have made there. Okay, so the key point is that variables that are nominal variables. That's the key. Variables that are nominal, okay, and you know them to be nominal, you can take the logs of them. Now, we have nominal variables like wage. Your salary is a nominal variable. GDP is a nominal variable. Inflation itself is a nominal variable. You can have nominal inflation and then real inflation. Okay. You can have a nominal variable like the exchange rate, the interest rate, the real interest rate. You have a real interest rate and nominal interest rate. Okay. You have variables like monetary variables. Monetary variables, because once something is a kind of a monetary variable, what it means that that thing can take the log of that. That thing, the nominal value can change, but not necessarily percentages. Not necessarily percentage. So some things can be converted into percentage and when you take the log, not necessarily. The variables like that can be affected by inflation. So in this very context, we did not take the nominal wage, but we took the real wage. We took the real wage. Okay. The logs will convert the changes in the variables into percentage changes. And that's why I say when the thing is already in percentages, there's no need. So when you're talking about return on assets, okay, you might want to take the actual return on asset, but when you're talking about the profit itself, you might want to take the log of the profit. Okay. But note that when you take the log, it will also change the way you interpret the results, because the results are now becoming elasticities. And there are so many relationships that are naturally expressed in terms of percentages. So when you take percentages, it can help. So that is the key reason is to be able to deal with nominal situations. Now, some of the variables we took the log, but some of the variables we also took the the squares of them. We'll come back to that. Okay, so you have this point there. The key reason for using the log of wage is to impose a constant percentage effect of the independent variable on the dependent variable. All right, so let's go to squares. Now, if you can remember, we took experience and then experience square. Why? And please, most of these things you have to justify it with a theory. Experience. Why do you think we squared experience? You can tell us. Why do we square experience? Why do we square? Of course, you are hearing that we do these things to handle the curvature or the non-linearities of the independent variable. Typically, the quadratics are employed. Okay? And this is to ensure parsimony. But that doesn't mean that because of that, you square everything. If you square everything, it can lead to problems. You know, it can lead to problems. So the best way to identify whether a particular variable requires a squaring is to use economic theory. Think. Use economic underpinning about that particular covariate, that regressor, that explanatory variable. Sometimes you may not need this at all. You may have to go and specify a nonlinear model instead of the normal OLS to deal with the situation. But for now, why? Because one of the things you'll be doing in your work is that you will notice that somebody has taken the log of something, but has written something, but that thing should have been logged, and that thing should have been squared. Okay, so why do you think somebody might want to square experience? Who can tell us? Why might someone want to square experience? Because the thing is that if a person's experience is rising and rising and rising, the squaring means that it gets to a point, it begins to fall. That is the essence of it. It gets to a point, it begins to what? Fall. So it becomes an N shape kind of graphing. And that might be true because a person can have a look at footballers, for example. The person might have an experience, and you get to a point, the person's experience starts diminishing. Somebody might say Messi used to be quite fantastic, skillful, agile, nimble, acrobatically precocious. And then the guy was just jubilating, used to dribble a lot of players through. But if you have observed this gentleman of late, you could see that experience is kind of going down. Have you observed that? Have you observed that? Okay. Or you know, yes, just type it for me. Have you observed that the experience is going down a little bit? Okay. I'm just using footballers because they tend to be in that situation. Gareth Bale, you know, he used to be quite great, wonderful. So when he was in Tottenham, he went to Tottenham, went to play to, you know, in Real Madrid, jubilated, and then now he's back again. He is back again. He said his form, we use the word form in football, his form has gone down. Okay. The same thing with, so when you have something that goes up, gets to a point, it starts falling, then we have to, you know, take the square of that. And another example is total assets. Some people use total assets to signify the size of a company. So if you want to know the size of the company, you proxy that with the total asset. Total asset is a great thing. The asset of the company is great, but it is believed that it gets to a point, the asset of the company begins to diminish. The size of the company begins to have a negative impact on the company. For example, a company with a size of maybe 10 people, the manager will be able to know everybody by name. There will be no checking of duties. Everybody will be working. But as time goes on and the company becomes bigger and bigger and bigger, people begin to lazy about. Some people do not know what they are even doing. No monitoring really might go on, and you know that will have a negative impact on productivity. You know, so as size is going up, as the size is increasing, as it becomes bigger measure, mega measures, okay, then that will deteriorate in profit margins. So this knowledge will make a person want to sometimes take the square of a particular variable. So you got to get a theoretical underpinning, the justifiable economic reasons for giving that particular thing. And you can look at it in several areas of things. Okay, so that is where the square, the non-linearity comes in. You have to argue it out. The third thing you will notice is that some variables may be interacted. You can interact a variable. A variable you can interact, okay? Because you believe that two predictors, they affect the dependent variable in a multiplicative way, not in additive way. And so you try to interact them, but you have to get a justification. I'll give you an example. Let's take an example. We all know the relationship between competition and profitability. It is believed that when firms are very competitive, they tend to be more profitable. That's the general belief. When firms are competitive, they tend to be more profitable. Okay, but then when firms are competitive, somebody might say that if you are competitive, but you are not diversifying, okay? You are not diverse, you are competitive, but you're not diversifying into other products. What is going to happen is that it can affect your profitability. So if you diversify whilst being competitive, it can lead to a higher profit margin. And so you can interact that diversification element with competition. And then you can use that as a way. There are several other things. Capital structure. The value of the firm is independent of its capital structure. Modigliani and Meller's proposition. When people make some of those things, some of them, it will only work when you now interact with other things. So you might look at something like you can be big. You can be big. Big is better. Yes, big is better. But then you can grow and become big, and yet you are not differentiating your product. You are using the same product over and over and over again. So somebody can say that product differentiation can be interacted with size. So if you are getting bigger and you are differentiating yourself, it might make somebody might lead to profit margin. The most important thing is that you must back it up again with theoretical reasons anytime you are doing this. So please learn the interaction part. Okay? It can be done with both independent variables and binary variables. Okay, so you have an independent variable, then you interact the independent variable with a binary variable, okay, where one is binary and the other is continuous. And you can also do it with two dummies, two binary variables. So you can interact with two dummies. Or you can interact even with two continuous variables, like what you see here, x1 multiplying. Now, when you're interacting, it's simple. It's just a matter of go to that column and then go to the second column, multiply this one by that and create a third column. That's the interaction. And you can apply that. So that is the way to go. So with this in mind, we are now ready to do a general panel model, this time using our data set.